All right, now that we are done with our unit on algebra, we are going to go back in the book, all the way back to chapter 1. We're going to start here in chapter 1, lesson 1 on page 10. Let's go to example 1. It says, Adrian biked 24 miles in 4 hours. If she biked at a constant speed, how many miles did she ride in 1 hour? Well, the question here is, how many miles did she ride in 1 hour? And the important thing here to note is miles in an hour. We are looking for a ratio that has miles on top and hours on the bottom. So miles per hour. So then we can go back into the question and find those facts. It says 24 miles and 4 hours. Then we want to turn that into a unit rate. How do you turn it into a unit rate? Simple. You take this ratio and think of it as a division problem and divide the top number, always the top number, by the bottom number. So 24 divided by 4 is 6, and it's 6 miles per hour. Okay? Let's go to example number 2 on page 11. It says, find the unit price if it costs $2 for 8 juice boxes. So we're finding the unit price. This is important because the price is the thing that's got to be first, which means when we set up our ratio, it is money that needs to be on top. And the single thing needs to be the boxes on the bottom. So we're looking for money per boxes. Well, it's $2 for 8 juice boxes. So $2 for 8. Well, I want to get this down to how much does it cost for 1 juice box? And immediately you want to say 4, don't you? But that's not the correct answer. The correct answer is actually 25 cents. It's 25 cents per box. But you're saying, Mr. Mann, it's 8 divided by 2. No, it's not. Remember, I said always divide the top number by the bottom number. That's a capital A, capital L, capital W, capital A, capital Y, capital S, exclamation point thing. Always the top number goes in the calculator first. Always the top number goes inside the box when you're dividing using long division. So it's the smaller number divided by the bottom number. But the bottom number is the one that has to be a 1. So that's why we divide 8 into 2, and we find out it's 25 cents per box. So remember that. Always the top number being divided by the bottom number. Take a look at example number 3. It says the prices of 3 different bags of dog food are given in the table. Which size bag has the lowest price per pound, rounded to the nearest cent, which means to 2 decimal places. With money, we always round to 2 decimal places if we have to have a decimal. So which size bag is the lowest price per pound? So again, this is money over pounds. And the thing is, we need to compare 3 things. So we're not going to have to do 1 unit rate. We're actually going to have to do 3. So I need to set up this ratio 3 times, not once. If you're asked to compare, you will have to do 3. And those are pounds for those of you who are very not paying attention. That's not a 16. Those are LB pounds. So the first bag of dog food says $49 for 40 pounds. The second one says $23.44 for 20 pounds. And the third one says $9.88 for 8 pounds. So I need to pull out my handy dandy calculator to do these problems, because even though I can do long division, why would I want to spend a whole lot of time doing it? And I'm going to take the top number and divide it by the bottom number. Always the top number divided by the bottom number. So 49 divided by 40 comes out to be 1.225. I need to round that to the nearest cent. So that's going to be $1.23 per pound. So I divide the top number by the bottom number using my calculator. Then I take $23.44 and I divide it by 20, and that comes out to be 1.172, which is approximately $1.17. I left out my decimal point up there. I'm sure somebody was thinking that already. $1.17 per pound. And then I take my $9.88 and divide that by 8. And that comes out to 1.235, or approximately $1.24 per pound. So the question was, which size bag has the lowest price per pound? Well, this $1.17 per pound is the lowest price. So the answer to the question is the 20-pound bag. And I should make it look like 20 pounds and not 201. Or again, somebody not paying attention might think I put 201 there, or 2016. So a 20-pound bag is the better price. That brings us up to the last example, which is on page 12. It says, Lexi painted 2 faces in 8 minutes at the craft fair. At this rate, how many faces can she paint in 40 minutes? So, again, because these are all in word problems, we need to make sure that we're finding what we're looking for. It's at this rate, how many faces, that's what we're looking for, can she paint in 40 minutes? So we're actually looking at faces per minute. So when we set up our ratio, it's got to be faces on top and minutes on the bottom. Faces per minute. So then I can go back and look at my facts, and I see, okay, there's 2 faces and 8 minutes. And I can put those in the correct place in my ratio. Now, there are 2 different ways I'm going to teach you to find the answer to this question, because it's not asking what is the unit rate. Go back to the question. It says, at this rate, how many faces can she paint? We're not asked for the unit rate. However, we can use the unit rate to figure out this answer. So that's one method. Method 1 is find the unit rate. So, like I've been doing, I'm going to divide the top number by the bottom number. And when I do that, 2 divided by 8 comes out to be 0.25 faces per minute. In other words, she can't get a whole face done in 1 minute. She gets a fourth of a face, or 0.25 faces done per minute. So then I'm going to have to take that and find out what that would be for 40 minutes. What would that be for 40 minutes? So I'm going to have to multiply that times 40 minutes so that I'm getting rid of the minutes and I'm going to be left with the faces. So still using my handy dandy calculator, I can take 0.25 and multiply it times 40. And when I do that, it comes out to be 10 faces. That she can paint in 40 minutes if she's painting constantly. Okay? That's method one. You find a unit rate and then you multiply it by the amount of time. Notice the time has to be the same. So if we're given minutes and hours, we got a whole bigger problem to face. As long as we have the same unit of time, this works. So let's go back and do method two. We're going to do the same problem, but instead of finding a unit rate, we're going to do something different. It says the same question, and we have the same rate. She can paint 2 faces in 8 minutes. But what I want to know is how many faces can she paint in 40 minutes? We can use something that's called a proportion in order to figure this out. And we're going to get deeper into proportions. But for now, just know that you can get, instead of a unit rate, we can put the same units on the bottom of 2 ratios and the same units on top of 2 ratios. And form what's called a proportion, putting an equal sign in between them. If you can do 2 faces in 8 minutes, how many faces, we'll call it F faces, we're going to put in a variable because we're going to use algebra here, in 40 minutes. The way you solve a proportion and figure out what F is to cross multiply. So I would say 8 times F. Well, since we don't know what F is, we're going to literally just write 8F. Because in algebra, putting a number next to a letter means to multiply. That has to be equal to 2 times 40. Because if you have 2 equivalent ratios, when you cross multiply, their products are equal. And I do want you to write 2 times 40. Now, how would I solve this equation? How would I get F by itself? How would I isolate that variable? Hopefully you're thinking back to before break and you're going, oh, that's easy. You just divide both sides by 8. The 8s will cross off, leaving you with just one F. And then you have 2 times 40 divided by 8. Well, I personally would do the 40 divided by 8 first, giving me 5 times 2, which equals 10 faces. To me, method 2 is the easier way to solve this problem because I don't really have to do 2 problems. On this top one, I had to do 2 problems. I had to, first of all, find the unit rate, and then secondly, I had to multiply by the 40 minutes that we're talking about in the problem to get 10 faces. In this second method, which is called using a proportion, I only had to cross multiply and divide. I think as we go through, I'm going to do this method more often just because I think it is the faster, quicker method. Even though it may look more complicated, it really is not. So that is the final example for lesson 1. please go ahead and do the letter problems, which we will go over in a little bit.